Welcome, part 16. Yeah, after 1 week break, we are back at our little Core XY machine here. I was actually quite busy preparing stuff. I had quite a busy week the week before, so I wasn't really able to like prepare everything. But yeah, like I have tons of new parts on the table. Basically what we were gonna do today is like we completely replace the bed mount. So basically the entire thing will be replaced. I hope the parts fit because I only like virtually fitted them in Fusion. Um, and it should fit, fingers crossed, but yeah, there might be some issues. I'm generally positive. So tons of parts. What are we looking at? We also see two new rods. So basically what we were going to do, let me just quickly park them on the side. What we're going to do on this beautiful machine is just get this in view. So we will replace the turquoise parts in the front. We will replace all the parts in the back here. And we will completely remove these four pieces here and the entire bed mount. The new parts, I'm just down a bit. Hi, Harlem. The new parts, if you just look at the front part here, so this is the same part as this. You see the new parts have this like new edge here. Like, I mean, you don't really see it, but there's nothing here. And what this does, it's actually the corner here for the bed. So this screw here in the corner of the bed will go in here together with the spring. So you see basically there's like space for the spring. I kind of like zoom around that, and it was a bit too much. So the spring basically goes in here into this pocket basically, and then the corner screw goes through here. So basically the corner will hold up the bed. You see at the moment we have like these two parts left and right here, and there's two rods that go under the bed through. And we have these bed clamps here where the bed then mounts to, which is like not a good construction. The idea behind this one was here that you can like have different sized beds and really easily adjust the bed mounts. So technically, like if you would have a bed with like 4 screws in the corners, like an Ender 3 bed or something, like you can still mount it using this. At the moment, we only have 1, 2, 3 here. So we have a triangle basically. So one in the back, two in front. So after this change, we will have basically four corners. The other thing why I want to switch to 4 is also like it's really wobbly in the corners here. And I mean, you can see it, right? Like the bed moves very easily. And I fear that if we now add a probe, that the bed is not really stiff enough to like trigger the probe and not deflect. So yeah, basically all 4 corners will hold the bed. These center pieces will go away. And that actually opens up quite a bit of space here next to the bed. And we are going to install a probe. And it's a Klicky probe. So basically how it works is we have here on toolhead, I mean, you kind of have to trust me, but there are 2 magnets here on the side, like here under that fan. There are 2 magnets. And we have this little carrier where the switch will be housed in. And that switch carrier basically attaches magnetically to the bottom of the tool head here. So we will have a probe dock on the side where basically the tool head will pick up the Klicky probe, will probe the bed, and then like return it into the dock. How will the dock work? So for the V0, let me actually quickly pull it up. There's a project called Sideswipe, and that's basically, no, not Rocket League. Oh, Slide Swipe, my bad, Slide Swipe. And hi there, Steve. Here you can see it in action. So this is on a V0. And you see basically here it's deployed. So the dock deploys, the toolhead grabs it, and then like you can start probing. And here it's basically stowed. So toolhead returns it, and then the probe goes in. or like the dock goes in. So that's slide swipe. And it's really cheap. Like the bomb is, yeah, it's basically like a micro switch. It's a servo, which is like also like super cheap. Couple of screws, couple of magnets, JST housing, and that's it. So in the end, like the total cost basically of the thing is like less than 10 euros. So it's really cheap. So I'm actually like kind of considering adding it to the V0 as well. Yeah, so this obviously doesn't quite work for us because it's a V0. We don't have a V0 here. And the main problem that I faced was that there isn't really a good spot to mount that. So you could say like, oh yeah, why don't you mount it here, for example? But the problem is that like in the forwardmost position, that's where the tool head goes. Like we actually still have a bug in the parts here, right? Like there's the front idler of the Z belt that blocks the tool head from going all the way forward. But even if this is removed, there's no space here to mount anything. My stupid thinking was like, oh yeah, I can just put it below that front corner here, like here. But of course the bed goes up there, so this rod is like used for Z for beds. It also doesn't really work. Then I was thinking like maybe somewhere in the back you can maybe have it somewhere here and then like kind of like deploy forward, but it also is like I have other plans for this space here. So yeah, it didn't really have like a good spot. And now the solution is after we remove these two brackets here, the entire side of the bed is free. So what we are gonna do, this is kind of like this is actually like the slide swipe. I just put this together to kind of see how it works. So this is basically for the V0. How this is gonna work is that this will be, I just put it above the bed now, but like it will be later below the bed. It will just deploy this upward here and then stow it away flat. So in a stowed position, it will be kind of like on this height here, so lower than the bed. So like there's no like impact on the motion. Hi there, Ravenskeeper. And then basically deployed, it will move up just above the bed, basically, that the tool head can pick it up. So that is basically the little trick I do. There's one downside. I hope I can fix it in the future. But technically what you can do is you can use the probe to home that. So on other machines, you would pick up the probe and then move the bed up until the probe triggers. So the probe becomes your Z end stop. The problem now is because the probe is mounted to the bed, in order to pick it up, I first have to home the bed. So not super ideal. I have an idea how to fix that. But for now, this means we will like keep the end stop switches in the back. Hi there, Blocks. Sorry, Blocks reaction. Hi there. I joined late. What was the servo motor for? The servo motor is for a Klicky probe. So we'll have a probe dock here on the side that basically deploys this little like sled here, which will then be picked up by a tool head to probe the bed. So that's basically here on the side, this like upward movement. Yeah, that's kind of like the theory. So we will change the bed mount, and then I hope we just have enough time to also install the servo. So yeah, I'm already talking like way too long. So let's just dive right in and get started. So I guess step one, disassembly. Let me actually all the new parts just like to the side. So, oh, that's actually a smaller one. Oh, and just as I now disassembled it, I realized I actually did not print new these levers. I didn't print new ones. The old ones here are like these. I didn't print new. The old ones are slightly too wide. I think actually we can just use like cable. Just try this. Maybe we can just shorten them manually. Maybe it's better to, I'll use knife, but let's just shorten them and then like problem solved. And I have not enough. Okay, maybe problem not solved. Problem for later. Let's see. Let me actually collect all the hardware. and this little thing so that we just keep everything kind of together. I'm not sure what we need later on to put this back together. No, my hope was that we can just fold the bed kind of backwards and like kind of like get it out of the way, which kind of seems to work. Okay, you just stay there. Cool. So that's kind of like our like undercarriage. I don't know what to call it. And as always, if I design something, tons and tons of screws. I feel like I'm a little bit like over engineering certain parts. That also means we actually will have to tension the belts again after we are done. So otherwise, again, let's see. So I think we can kind of like get this out. I think I'll disassemble these just tomorrow. I don't think we need to reuse anything directly from here. So it's actually quite peaceful work taking prototype parts apart and like I'll recover all the heatset inserts, all the screws, of course. So nothing goes to waste here. Let me just pass here for now. I want to ask you about something in the mounting bracket for the Manta 4P. Yep, I put it on Thingiverse. Not Thingiverse, printables. If you look for if you just search living room workbench on so like my YouTube channel, if you search it on printables, you will find my account, and if you check for models, it's the latest model. I can also actually just paste the link. Here you go. That is my mount, including the fan mount that I added after the stream. I don't think I showed the fan mount on stream. Want to try Klicky, but I don't think Patchy will hold long. I think Patchy will be fine. Like, if you don't enclose the printer anyways, I mean, the main problem with Patchy is that it creeps over time. But that only happens really if you put stress on it. So if you print, I don't know, like for example, like one of these corners here from Patchy where you have like the tension here, the bottom part will just deform a bit over time. And that's less of an issue with ABS. Actually also happens a bit with ABS, but way less. But in a Klicky mount or probe mount in general doesn't really have stress on it. So I would go for it. I mean, worst case, what you can see, like you see that your results are drifting over time. So for example, like you have to constantly change the Z offset. There would be like indication that the probe mount is not working well. So it's not like a horrific thing, right? Like it's not like that it like breaks in half and like your printer bursts in flames. Worst case, it doesn't work, and I have to like find a solution. By the way, I'm just like pulling out a couple of screws from these parts. That's the last one, and these can actually straight go to the bin. I was looking for it had a DIN rail, but it keeps snapping. So unscrew mod M4P straight to extrusions. Yeah, like I think that's like a better solution than the DIN rail, to be honest. Like also, like in this specific setup in the ender wire, um, yeah, I tried figuring out how to use DIN rails to place it, but didn't really succeed. Okay, so I'm just removing the tension from the belts. Then I would say we can just like do one corner after another. Let's see. It's a bit stupid with this like beam here. Like, let me just try to give you a bit of a back angle here. Oh, now it focuses on the lamp that reflects. Amazing. Yeah, now it is. We also will have to place some heatset inserts. Two screws holding mount might work. Yeah, for sure. I mean, really, just try it. Oh, this one is tight. There it comes apart. So the black part we will actually reuse. I don't think that changed. Same for this clamp here where we clamp the belt. So how this works is there's like basically like these tracks here and the screw. And then we have this like clamp for the belt. You see like the belt's kind of like clamped in here. Focus. So the belt's kind of clamped in here, and this has the same shape as the cutout. And the screw basically just goes in here and then like pulls this up to tension. And on the side, it's just like, you see like there's like the pattern of the belt. So it's just like clipped in. Okay, so let's replace this part. Which means we actually need a soldering iron. And it's like reflective thing. It's like quite annoying. I was looking especially when you're working on printer a lot. Yeah, I think the DIN rails work fine with smaller electronics, but if you have like a big board on it, I don't feel like the printed mounts are good enough. Okay. Let's do the same thing. Like I will recycle these later. Then I can just use new ones for now. Let's see. So this one's apart. I'm actually wondering, should we just do all the heatset inserts in one go and just get it done? Get it over with. Yeah, let's do that. Let's do all the heatset inserts. So that means we need these two parts. Let's do the heatset inserts for the bed. So this is the back part where the spring goes in. And that's the opposite side. So these have 1, 2, 3, 4. And these are actually really big parts now. Like these are the corners in the back. So these have 1, 2 for the end stop. 3, 4. And that's actually it. There's not too many. And then this goes together like this. I'm actually running really low on the turquoise ABS, and I already mentioned like I'm not gonna order a new one. So at some point the parts might just be all black. I didn't even check if these parts had to fit together. Like I was very confident. It looks like, I mean, this part's still here for the opposite sides. Looks like we got lucky. Yeah, the rest of the parts are all for a probe. So these are all the bad parts, actually. Let's get ready to do some inserts. Oh, that was absolutely not straight. I'll fix it. And two for the end stop. There's somebody on stream at some point like complained that I put on the the inserts with my fingers. It actually like works. Like I feel like that's the best way to do it. Just need to be careful to not burn your fingers, but besides that, it's very easy. Now I almost burned my finger by holding it on the back. Oh, I think you don't see anything of what I do. I'm very sorry. So these two are done. Halfway done. And last part with only two. No, four. But yeah, so my end goal is really like to remove this part here. Like we only need this for the end stop. So my goal is to get rid of these end stops on the bed and only rely on the probe. Let's just quickly double check that we didn't forget anything. No, looks good. This one doesn't have any. Cool. Quick and easy. Okay, let's see how we get this like. Maybe if I just show it here from the front a bit. I think this should work. Okay. So this is one part, and this is the other. So this is how it goes together. And this just goes around. Yep. Goes around that bearing here. And then on the side, let's just put in the rods already. Okay. Did I pull out? Yeah, I removed the screws. So I think from the front that were like shorter screws, 3x8, if I'm not mistaken. Just nope. Maybe let's actually start with the ones on the side. And let me actually, for these ones, use the bigger driver. Oh, that's too small. There you go. It's much easier to like use the big one for these screws that are like a little bit more tight to drive in, because like they compress the plastic around the rods. Okay, let me carefully just move this halfway up. Okay, let me see. So how does that work now? So this goes around, and we put it in somewhere around here. Sorry for my head being in the way. So this just slides in, and then later we can like loop a zip tie through here to secure it. Okay. And this needs to go around here. And then this basically just goes in from the bottom. Here we go. And then we use one of these longer screws here from the top. And this basically now pulls this like little like slat that we just put from the bottom. Just pulls it up, and like the more you pull it up, the shorter the belt path becomes. And I already noticed I massively screwed up. Oh, that's not good. I mean, you still can't see it. Can I show this from a good angle? So basically, I added this corner here, which now cuts into the belt path. So that's not good. I didn't model the belts in Fusion. That's why I didn't notice it. Okay, fun. So it's basically this corner here that causes problems. I don't even think how do we solve this now? That's not good. So I mean, like we can redesign the part easily to have like we can connect these two parts here, like just fill this whole area, and then have like a hole where the belt can go through, like just like a cutout for the next iteration of this part. For this part, let's do some on-the-fly modding. Prototyping is fun. Lesson learned, model your belts. I doubt this is enough. I think we need to actually cut on deeper, which then most likely like makes this arm not super stable. Okay, let's get this part out from here. And try again. Yeah, I need a torch lighter. That's actually not something in my arsenal yet. I wanted to buy one actually for cooking, to caramelize stuff. Should have done that. And to be honest, it kind of works fine. With the lighter as well. So there are also these like I want to say knives that are like heated, like that are like specifically made to like remodel 3D prints a bit. Forgot how they're called. How to make a mess. So I'm trying to just cut out like a little bit more here. I think we need it. How do I do it the best? Like technically, I kind of need to cut here, but to be honest, let's try this. Yep, that worked. Let's give this a shot. I think it's actually enough. Yeah, I think it works. So, I mean, I can't really move it because the motor is engaged, but, or not engaged, but like, yeah. But you can see like this kind of works. Actually needs a tiny bit more. Hot knife. It's like soldering iron with blade. Yeah, exactly. Soldering iron with blades. That's basically what it is. A Dremel would be good too, yeah. I don't like Dremels. I don't know. It always seems like very dangerous to me. Let's see. I have the perfect key file over there, I think. Right, let's just use the knife. Yeah, it's like definitely like less stable, but I think it's for prototyping, it's good enough. Also, this is fine for prototyping now. Like we're not putting like a million print hours on that now. So just kind of copy this. So this is kind of this. Let's do a bit more. So this needs to be gone. Oh, I need to be careful. Now I almost split it. Step by step. Yeah, luckily, like this is like easy change to model the part, or like easy change to the part. Okay. Okay, let me quickly get the, I have a square key file. Let me just quickly get that and we can kind of like clean this up a little bit. And then I think this is kind of like a usable solution for the stream. Okay, let me quickly grab that. I'm back in like for 30 seconds. A square key file. So, just luckily ABS is really easy to file. With PLA, this would be like a massive pain. It's actually still quite stiff. Surprising. But yeah, like, so the final solution here would be for me just like to connect these two, like basically fill this gap here. And then where we now cut a hole, I just make like a square hole. And then you can just put the belt through from the top and then problem solves. It's even more stable than before. Okay. I definitely have to vacuum clean tomorrow. Cool. Attempt 2. Ignore that this ever happened. And I also will add actually the belts to my 3D model. This was not really necessary to have the drama. But it's always the thing, right? Like you don't account for something in your model, and like reality comes by and says hi. Okay. Before I actually like just screw these in, let's just do a check. Yeah, now there's like plenty wiggle room around that. Like left, right is quite a bit of wiggle room, also backward, forward. So I think now we are golden. Just puts in a bit too tight. The Oh yeah, it's actually like a learning I had. It's actually better to loosen the pulleys later for tightening the belts. Where did I put now the long screw? Ah, here. No, this does not want to go in. Here we go. Now we can lay the tension this here using the screw. Perfect. Let's quickly put these two screws in. These two screws are kind of unnecessary. They're only there for optics. Just like because I have two screws here, two screws here, two screws here. It's just kind of have the line, but they don't fulfill any meaningful task. I think I kind of did a shabby job with the heatsink inserts. Like there's a bit of like friction in these two screws. But yeah, besides that, this is our bed mount. It's kind of like, yeah, it's definitely like not as stable as it used to be without that cutout here. But yeah, we can definitely stabilize that later. Like this is totally fine. And there's no downside really to like having like just like this closed and having just a hole here. As I only use GPLA for my prototyping, 90% of it ends in the trash. Yeah, it's actually like in the beginning, I also like prototype with PLA. But the problem is with PLA prototyping, the parts were not strong enough. Like they just fell apart. That's when I switched to ABS. Also for the prototyping. Yeah, I really have to use ABS. Like all the parts were basically cracking and falling apart with PLA. I'm not quite sure. It might have been just a specific type of PLA I was using. But yeah, still, I feel like it's better to prototype in ABS. The black ABS is okay price-wise. So I actually like, I'm not gonna use the teal ABS anymore, but only black. I mean, it's prototype. It can be ugly and all black, so no problem with that. Let's do the other side and then go to the back and hope that the back fits better. Oh, I think we actually put it incorrectly in on the other side. Yeah, the belt has, yeah. Yeah, let me quickly take this apart. Would have helped to just remove this here. So there's actually like a little hole here. You see where the belt feeds through, and this basically just is there that the belt path is vertical. I don't think like technically that's needed, but we should do this on the other side as well. Okay, so this part is out. That's all one. Let's get our Frankenstein part here. Yeah, the front screws are a bit difficult actually. I think I really just put the heatsink inserts not in straight. Oh, it's not a problem before. Klicky Pajik parts are printing. Congratulations. Pajihot and Mont still going strong. What's the concern then? I Something is really off with these. Potentially also the holes shifted like ever so slightly, and that's why it's like not fitting super well. Okay, also here, let's carefully move that up. Okay, so let's do it properly here. So the belt goes through that little hole in the back. Then it goes in the clip. And then the clip goes in. And then we can tension. Okay, let's get this around the idler here on the top. Here we go. And the belts we need to tension, but now you can see basically the difference from what I meant with the belt path. Like here, the belt path in front is like perfectly straight. And you see the belt path here in the back, the belt is like leaning forward. And that's basically because it doesn't go through the little like loophole here on the back. Concern is overthinking, exactly. I mean, sometimes you should overthink a bit. I read that somewhere, like some decisions are doorknobs and some are door handles, I think is the translation. So if you make a decision with a doorknob, the door is closed behind you and you cannot like open the door again. And then decisions with like with a handle, basically you can undo the decision because you can go back through the same door. And patchy Klicky mode definitely is like a door handle kind of situation. Okay, let me loop that through here. Tapered belt is fun. To be honest, I don't think it does anything to the precision or something. Right. Where is the hole? Oh, the other belt is over the hole. Okay. Here we go. Here's the belts. I cannot put the printer on the side really because of the bat, which makes this entire thing a bit difficult. So this needs to go in this orientation. Here we go. Now it fits. Perfect. Only problem is now it slipped over the idler down here. Oh. So make sure that you see something. Okay, this belt needs to go over this idler. To be honest, let's just do it the following way. So, Go. Tension, problem for later. Okay, 2 corners done, 2 left to go. We're thinking you should make the bed mounts be separate parts that bolts to the bearing block. Then you can have bolt a new one if break or bends. It's actually a good idea. So I'm trying to keep these parts like a single part. Just like that, it's like less screws and easier to print. But to be honest, there's like a lot of meat here where we can easily like add screw mounts. So that would actually be a good idea. Let me think about that because I also like because my thing is like I kind of want to make this modular for different beds. So this one is now 100% fixed for the Prusa mini bed. If we make these like modular, you can mount different beds. On the back side, it's a bit more difficult. There's not as much like possibility to do that. So I think that might be like improvement for like a later version. Maybe for now it's better to keep it simple. Not sure. Okay. But yeah, overall it's a good idea. Because I kind of lost now also the modularity. Like the benefit of this system here was basically right. Like you can place these clips anywhere on that beam, so you can really like basically mount any bed if that fits the size, of course. Okay. Oh, there we also need to remove that little cable tie here. And also this one. Because we need to remove that end stop here. What kind of printer are you using to print all your parts? These are all printed on the V0. That is my only ABS printer, actually. Okay. Let's transplant this end stop. Let's transplant this answer. So this part is recycling. This one is the new one. So the end stop is easy to add back. And technically you can already put it back. So the interesting part here is now, like before, it was really hard to position these parts like in this direction. But now, because it holds the print bed, it will be like a really defined position. And actually this now collides. Oh, wasn't properly in. No, it's fine. But yeah, so later we can like really position this that the bed is correct. And this is the counterpart. And like, I'm sorry, like it's a bit too awkward to make you see this on camera. Oh. Now the camera is a bit in my face. The other problem we had with the old parts here was that the belt path wasn't like vertical. This doesn't want to go in. Why does the screw nut doesn't want to go in? Yeah, here we go. Uh-oh. Something is not quite like there's not like a little bit of like a twist in here. Not sure if this could be because like we can twist the part still, but like here this is not like aligned. I mean, it's not bad. It will kind of like sort itself out. It's still like a bit concerning. Let's see. Let's also do the little trick with the belt here. So belt goes through the little pocket in the back. And then the tensioner can go in the other way. And it's really annoying. Like I can't really flip the printer over because of, I mean, it can technically. So yeah, here basically you also see there's like the hole for the tensioner. That was correct. No, it's correct. This kind of needs to go in here. And it doesn't fit. I think the dimensions changed. Oh no. Ooh. Height fit, but it's fine. So yeah, basically the tensioner just goes in here. And it basically has the tracks, and then the screw just pulls it up. And as it's pulled up, like it pulls the belt further in. Okay. Let's put this back up. And this was the part that was problematic before. I triple checked the 3D files and everything is aligned. Also now it looks better. So I think you fixed it before. Like the alignment. Like now it looks like this looks all parallel and vertical. So I think I fixed it before. Like I was like checking, I was like, I don't see anything wrong. No, it's still a bit off. Like if you look from the front, sorry, it's like there's so much stuff in the way. Oops. No, I killed the camera. If you look from the front, like the rear path here is not aligned with the front path. If I move it in a way that the bottom is aligned, you see here like the bottom is like perfectly behind each other. And then on top it peeks out. So this part is not like this edge here needs to be like at least like a couple millimeters more towards this direction. That like this belt is here. But if I do that like on the bottom, it's not aligned anymore. So it's not straight. I checked the files and like I did not see why this would be the case. Oh, actually, I think that the bottom one is wrong. Because if I kind of like align this on the side, so you see here like there's the end. So if I kind of align this to be straight more or less, the top one is actually okay. the bottom one is incorrectly positioned. I think that's why I didn't see it in the files, because I was like super focused on the top one. Okay, this means like we need to reprint these two parts as well. Yay, success. Okay, it's not worse than it was before. Just means it doesn't run like super straight, but yeah, it's fine. Prototype. Okay, cool. We can technically tension these belts. It's all fine. We need a couple more screws here. Oh, there is some inserts in there. So this goes for recycling. Yeah, but like there's some tension in these parts. Like something isn't quite. Let's check the other side. It might be the heatset inserts, or it is something in the file. Okay. But yeah, like overall, I think it should work for today. But it's always like the first time we put parts like these together, like stuff is always wrong. I think like my hit quota is quite good by now. And usually if it fits in Fusion, it fits in reality. But yeah, stuff can always go wrong. I mean, just here we go. Yeah, now we can tension, like with this screw, we can tension the belt. Cool. Yeah, one corner left. One corner left. And then I guess I first would put the bed and everything together and then tension the bed all at the end. Tension the bed. Tension the belts at the end. Oh wow, 18 people. Might be a record almost. Welcome everyone. Okay, already unplugged that, and then also remove the zip tie so we can kind of get rid of this cable. Let's take this all apart. Now here you also can see the tension mechanism like from the inside. So the belt comes from the bottom. The belt comes from the bottom, and then the screw here does nothing else but like pull up this like little slat here. And yeah, so this just pulls more and more belt in. And that's actually quite nice mechanism because it's A, very compact, and B, it allows me like you can tension quite a long length. So the belts don't have to be precisely the same length. You can kind of like make up for quite a bit of difference just with the tension mechanism. YouTube algorithm is working in your favor today. Yeah, like it's super random. I mean, this is my hobby. I'm not really doing this for like money or like something. But yeah, it's nice when people should watch, of course. But yeah, it's super random. Like sometimes it's like nothing, and then today it's like really good, but I don't know what the difference is. I noticed this machine or like this project is more popular than when I work on the Enderwire. Okay, new part. Let's pay attention if the parts are also misaligned here. Okay, this is in here. Yeah, they're also a bit misaligned. Funnily enough, in the opposite direction. So I think it's something assembly related. Let's not tension these too much yet, because we will have to adjust the length. Here we go. Oh no, it's actually the same. Like the black part here is like a tad higher than this one. It's kind of like, it's not a lot, it's like 0.2 millimeters or something. It's really like tiny bit. Not quite sure what the reason is. But yeah, we actually now also have to add these in between the two back corners. So okay. Now the interesting part is we kind of need to adjust everything. Like everything is kind of like super weird right now. So let's first just push everything down, and then we kind of need to adjust the width here, and we need to adjust the depth. So everything kind of like is weird now. So what I would do now, let's just use the bed to do the hard work for us. Let me just add the screws here in the back to hold it. Don't have to tighten that, just so it's not fully loose. Sorry, everything's out of focus again. I'll fix this in a second. Okay, so I'm curious to see if this later is like good enough. It's a bit wiggly. So we have now the four corners here. And I think like my plan would now be to use the screw holes of the bat to align the bat, to align the corners. So I'll just maybe a bit shorter screws. I do this now without springs, so that the springs don't like add some imprecision. But I already noticed like these two are like not very well positioned. It's not ideal. So like the screws are pointing outward a bit. You can see here, like it's not pointing straight down. It's like a little bit like it's a little bit angled like this direction. So the hole spacing is not perfect. Okay, let me so here. So now basically we just need to make sure that this is aligned. And I think we need to have this. Oh, I already tightened these. I double tightened these. Wait, how can I? Okay, so let me just tiny bit over. Also here I tightened the one inward. Wait, you just maybe try to. Oh, we didn't even do the belt on this side yet. Okay, so this is clearly not well positioned here. Oh, go through. Well, it doesn't need to be super precise, right? It's just like needs to be like roughly in the right spot. And now we can kind of see just on the screws roughly that we are in the right position. So now it's like all the screws are kind of like pointing downward, more or less. So let's just tighten that. Hi there, Enlightened Savage. A secret to making your cheap 3D printer better and cheaper, use parts from old inkjet and laser printers. Yeah, that's always an option. You can get precision ground steel rods from these machines that cost nothing. Yeah. I mean, I kind of like left the super cheap pathway for a second. Not for a second, but like I really struggled to make it like super cheap. So I first want to build like a normal machine, and then we can see how we can make it a bit cheaper. But yeah, in the beginning, I had like all these like special solutions planned or like designed, and none of them worked like really well. And then I figured like it's hard enough already to design a 3D printer. You don't have to make it super hard on you by like trying to make it ridiculously cheap. Now this is, by the way, like completely flush here. So the rods completely fixed the problem because they kind of pull the parts together. Yep. Just Make sure all the screws are somewhat tight. Okay. And I think like the bed can leave its temporary position again. And these should be kind of like in the right spot. Still have to tighten these again. Actually, not sure if these screws are needed at all anymore. I think I can completely remove these screws because these two parts are held together here and here. Like this isn't really like needed. Might be even counterproductive. Okay, let's quickly do the belt on the back here. Just wiggle this up step by step. And then we can add the belt here from the back. Put it in the little clip and then feed the clip in. Here we go. And then the belt can just go over the idler here on top and be roughly put into position. Cool. Okay, all the belts are there. Obviously, they're like completely loose and floppy. We will fix this in the next step. Let's first get the bed mounted, actually. T, why are you confused? Are you not mounting the back to the other linear rods? No, I only have two mounted to linear rods. The reason is that it's with two, you have the linear rods vertically are only there to have the bed fixed in X, Y, right? So that it can't move back and forth, like left, right, back, forward. That's the only thing the bed, like the rods are for. The Z is done by the belts. So with two, it cannot really rotate. I mean, now it can actually bit, like there's a bit of flex. Before when I had these, there was like no flex in this direction. So maybe that's a weakness of design now. Technically, I could add also connection to the rods here. Might be okay by now, to be honest, or like required. In the beginning, it was not really necessary. Output ramps 1. It will sway a lot. Why would it sway a lot? Yeah, but why would it sway? I put RAMs 1.4 on an ANET A8. Only problem I had was instead of putting the two Z models on one driver, I use E instead. Why is that a problem? You don't have a driver anymore for the extruder? Because, I mean, you can have two different drivers run Z, right? It's the same what I have. I have two motors and they're two different drivers. Let me see. Somewhere in here, Yeah. I mean, first we can see if we can finally install that protector for the bad compress. Ah, here. There's a single spring which we now need. Um, um, from the head shaking the machine, maybe, yeah. I mean, might be. To be honest, by now, like it would be fine to just add it. Maybe if I add the connector to rear rod, I can even get rid of this, although I should keep it as well. I mean, initially the reasoning why I didn't want to add it was that I don't get a lot of binding. And technically this should be fine. Like other machines do it as well. Like, for example, the Rook, if I'm not mistaken, only has 2 in the front and nothing in the back. So it's not like completely unheard of. The reason why you would only have 2 is that you don't have issues with binding. So it's just easier to have 2 rods parallel than 4 perfectly parallel. From, yeah, Kara, I think you said the exact same thing as T. Um, for sure going to cause problems. Yeah, like here's the thing. I will have to reprint the black parts anyway, right? Because like the belt is not properly lined. Not much stopping me. Like it doesn't even have to have any like Z thing, right? Like you can just like literally like a hole where you just slide in the thing. I'm gonna add it. Um, yeah, I think T and Kara, you're right. Let me just add it. Now we have the problem out of the world. I think the rods are parallel enough, or we can make them parallel enough that sway isn't the problem. Actually, like that's not the worst idea ever. Just like for a very simple reason. If we have like the bed connected to all 4 rods, we can move the bed up, we can, or like down, whatever, tension the corners that like the bed fits, and then we can move it up to ensure the rods are parallel. So I think that's actually quite a good feature. David, yes, that's what I've done, but according to the setup, both Zetmos use one driver. I mean, you can also change it, right? You can just like you can just connect the cables, literally, like just a Y splitter, basically. There's nothing fancy. If you drive 2 motors from one driver, you can basically, all you need is like a Y connector, basically. You can solder the wires, or ideally just have like a Y connector JST. And then it works. The only thing is like if you drive 2 motors from one driver, is that the amperage is halved, or the current is halved. So basically each motor only receives half the current, which for Z is not super critical. Oh no. I think I've spotted another problem with my prototype parts. This hole is smaller than the others. It doesn't fit the spring. How to set amp spot? I have no clue. It's something with the voltage, but I don't know that. Technically, you can just leave it alone and see what happens. Hey, I was so confident in my parts. Okay, let's fix that. I was so confident. Yeah, so basically I have to reprint all the parts. Nice. Yeah, it's not missing like a lot. Now that the spring kind of already fits in. Oh, here we go. Not sure if the spring is like fully bottomed out in this pocket. I think it is. Okay, I'll have to increase the hole size. I think on all of them that they're like relatively tight on all. That was not the intention. Okay, let's put this on top. And then we also need the proper screws. I think these are actually too long now, but quite a bit. Let me see what my magic fastener box has to offer. So these are, no, actually no clue. Like they are not from this kit here. They're really long. No clue where I got these screws from. I think 28 should be fine. Yeah, 28 is perfect. I barely know how your machine will work at this point, so I'm probably clueless about design at this point. Um, it will become more clear in a second when the bed works. So basically we have two Z motors, left and right, and each motor drives two belts. So these two belts are driven by the same motor here. There's like a big gear here, like the motor comes out here, and there's like a 50-tooth gear. And then we have two pulleys here. So one pulley drives this and one pulley drives that. That's basically the concept. So it's not like a fully, like you cannot fully tram the beds. Like let's say like a Voron 2.4, right, would have four motors in all four corners, so you can tram the bed. So each belt has its own motor. In this case, basically, I mean, you could technically add like two more motors. It's just like it adds way more cost in this case, right? Because you need more motors, you need a more complex mainboard. Stuff gets expensive quickly. So it's kind of like a budget option where you can kind of like tram the bed left and right. So you can synchronize the motors automatically. But you are yeah, you're just like cheaper because you can use like a standard mainboard. Technically, you can also drive both Z motors from one stepper driver. The only problem with that would be that if you do that, then you cannot tram the motors. So you would need to do some hacks like driving the motors into the end stop to like level left and right out. Okay, so these two are fine. Now for the back, I think the problem will be we actually move the bed up a bit that we can like put in the now I can just access the back screws here. I think these don't fit. Yeah, exactly. Like I cannot twist these here. They're like too big. So for the back, I think we just have to live with M3s, M3 nuts for today. Oh, actually, I have these thumb nuts. That's actually not the worst option at all. I think we can just use them like permanently. Man, they're made for that. They're made for that. Could you trim the T-handle with some snips? Yeah, I could, but I also only have 3 of them. So for one, we need a special solution anyway. Because before I now like changed the bed mount, I only had 3 mounting points of the bed. So like 3 springs. And I totally forgot to change and print new ones. But it's actually like they work really well. Like I can really easily like twist them. You know what? Let's leave them for the front. I really like these T handles. Okay, so that's the bed. Now the interesting part. So we removed the strain relief here. That also like kind of protects me from touching it because we didn't have enough space. We might now just have enough clearance to add this back. Oh yeah, it's actually should work. I still might. Oops, I still might design like more compact one. Server time. Not yet. Let's first make it kind of work. How does it come together? Trying to figure out why this doesn't fit. I think these need to be a little bit more inward angled. Man, this part. Like somewhere it doesn't come together, but don't ask me where. Oh, I think it's a... Okay, I really don't know where it is. Okay, I'll do it another time. So for now, we have to lick it out. Technically, from the bottom, like you can't touch it anyways. So maybe if I just print something that covers like the 2 screws here, it's already good enough. You still should have a strain relief. But yeah, it worked so far. Let's not worry about this. Cool. Oh, we still need to connect the end stops though. So we have one cable here for this end stop here, and we have a second end stop on this side. Let's also go through the bells here. Same thing as on the other side. And we have like a little like zip tie loop here. That's a bit difficult. Could be a bit wider, I think. Okay, so this is fixed. Let's do the other side. Oh, it broke off. So there could definitely be a bit more space for zip tie to go through. I don't think it was like that tight for the last part. Maybe something changed. This side is tighter than the other. Okay, that zip tie is done. Let's try one more time. The tip goes fine. It's just like the main body. Okay, the zip tie was easier. Maybe the other zip tie was like a tiny bit wider or something. I don't know. Okay, so the end stops are fine again. Then let's go through the horrible task of tensioning the belts. And then I would just do like a quick run, just see that everything works, and we can like work on the Klicky probe. So I quickly put back some tools we no longer need, just to keep everything tiny but tidy. Okay. So let's just put the bed relatively far up. And what I noticed or learned last time is basically, so the construction we have here is that the motor is here, and we like have this 50-tooth gear here, basically with that belt in the middle. The problem is now if I tension this belt prevents the shaft from turning. So the let's say like the bottom part of the belt here then tensions, but the top part doesn't tension. So the tension of the two halves is uneven. And the only way I kind of like managed to fix that is you have to loosen the pulley screws here, which does mean you kind of lose the flat side of the shaft, which is not ideal, but I don't think is a huge problem. Technically, should also like not rotate too much. So with that being loose, we can now start tensioning the belt here. Because now like the pulley on the back can move freely. What motherboard said, never seen that small before. This is most likely the smallest motherboard for printers of all time. It's really small, like it's like check card size, basically. It's smaller than a Raspberry. That's a Mellowfly Micro 4. Has 4 stepper drivers. You see here like the blue cooling blocks. It doesn't have too much stuff besides that, obviously, because it's just super small. What it does have CAN bus built in. So there's a CAN bus adapter here. So the small plug here, basically, these are the CAN high and low for the toolhead board. And toolhead board then just drives the toolhead. So it's like a really, really sweet board for this printer. Later, what I want to do is there's like a column basically here, like a backpack, but like inside with electronics. Electronics being this main board and the Pi Zero that's currently under deck here. And this is actually quite a cheap board. It's like 25 euros. It has everything I need, and it's super small. So, hey, it's actually like a really nice board. Documentation is so-so. But yeah, it's a board. It runs, I think, on the RP2040. It runs on the RP2040. Yeah, RP2040. So yeah, it's like a nice board. It does all the things you want the board to do. I'm gonna get one now. Do it. Like seriously, like if I would build a V0 or something, this would be like really high up my list. I mean, like for the V0, there's now also like the boards like the M4P, for example, right? Where you have like the like Raspberry and the main board in one board. Which maybe that's nice, but like just like combine the size of the Pi Zero with that, like you won't get anything smaller. The only thing, like that's really like missed opportunity. I would have made this tiny bit bigger and would just have the whole pattern of the Raspberry. Like if that would have been like just a Raspberry whole pattern, man, it would be amazing. Like Raspberry whole pattern, and then like most of the plugs, like the SKR Pico, like to the outside, that you can like basically put the Raspberry on top. They just have like a hat basically for Raspberry. That's a printer mainboard. Would have been amazing. But yeah, nothing is perfect in life. Let's get our belt tension meter friend. I am going to tension on the front belt here. The tension at the moment is 0. Let's tension that. Let's actually try to yep. Actually, this can just, yeah. Let's actually try to pre-tension it a bit. So I'll just try to like get 1, 2 teeth like down here from the clip. And now we are already at 2. Maybe that's done too much. So my target would be like 2, just like straight 2. It's just like an arbitrary belt tension I now choose. Would be just 2. So now we are at a little bit below 1. So we can tension to 2. Just like to show you. So this is what I'm seeing. You know, actually like quite a bit over 2. I find it quite important to like push this in, that you get reliable readings. Just to reset basically the measurement after you changed it. And sometimes you get a false reading, so like I always check like that's like 3 times in a row the same value. So now we are like at 2. I can't find documentation on the exact board. Let me show you. Um, so this is a mellow fly micro 4. It's this one. Mellow fly micro 4. And there is the mellow documentation really sucks. That's like one thing I found out the hard way. They have also multiple documentation pages. I've never seen this one before, for example. Um, yeah, and somehow it doesn't translate. But yeah, this is documentation. You just have to like right click, translate. Here you go. Solid Mellow, but the website calls it different names. Can't find the right one. So this is the documentation. Like the Mellow documentation is a bit messy. I can 100% confirm that. And this is the AliExpress listing, I think, where I bought it. Don't ask me what shop that is. Like, no endorsement. This is just the first link. This is actually Mellow 3D official store. So here you go. Man, the VZ bots are also quite nice. Maybe at some point in the future. Cool. So we have one bell tensioned. Let's do the back one. Also using the forward one because like the height is like the same, so it's more or less 15 centimeters. Let me see if where I can poke. I was like, where did like this heat shrink just fell out? And I said, where did it come from? It's the heat shrink I added to my screwdrivers to mark the size. This one seeming is a bit loose. That's like green is the normal one. Don't ask me. 2.5 is green. It's also the same here. Let's just try to like add a bit more tension by just like going like 2 teeth down from the clip here. Oh, now we are already at 2 almost. Yeah, just checking the screw is actually doing something. It's a bit random right now. Yeah, that's good enough. So that's 2. Let's not forget to tension the pulleys again. Okay. One side done. One side left to go. Let's also start here by loosening the pulley. Oh, funny. I think I forgot to tension him last time I did that. So this one is loose. Technically, it should be fine if like one is loose, the other one can be fixed. Okay. Let's just move that up. I'm looking at the git. I see the fly SP2040 fly 40 something fly, but nothing says the micro 4. I will need to check again later. I want to see how many fan headers are configured like PWM. Click the link I sent in chat. That's the docs, and then you just have to translate them to English. And then you should be where you want to be. But yeah, like the amount of fan headers and stuff like that is a bit limited, of course. Just like because it's very small, like it's just physically not a ton of space on the board. Okay, this is 2. Yeah, and that's fine. We can now tension also the front one. So it's enough if one idler is, well, one pulley is loose. It's also like horribly loose. So let me just pre-tension it a bit more. Oh, it's already too much. Hey. Oh, that was easy. Perfect. Okay, now we just have to fix this pulley again. And let's also double check that the other pulley is fixed. Yeah, okay, cool. Okay, well, the belts are tensioned. So technically we can start the machine up and home. And then we just need to like level the bed, basically. Let me quickly check T. So this is the listing here. Translate to English. Motherboard wiring. So that's the pin out. So you have fan 0, fan 1, and fan 2. Fan 2 is always on, right? It's just ground and VCC, so that's hardwired. But you have 2 fans with GPIO headers that you can PWM control. Technically, you could also have one more fan header here. You have GPIO 12 and VCC. So technically, you can function this port here also as a fan, right? That should work exactly like the fan ports. Um, and then like another thing you can do, like I have a tool head board, which means I don't use the heat zero here. No, you don't see it. Like this one for me is free because the hot end is like from the tool head board. So you can also connect a fan to this one, a bit like not like I mean it does the exact same thing. It's just a VCC and GPIO 20. Um, I have like a random thing there. Okay, yeah, but that's the thing with the pinout. Cool. Then yeah, like let's just start up, level the bed, and off we go. I'm going to get one for sure. Thank you. Yeah, it's like I don't know, like this. I never heard about the board before. I just like randomly saw it while like looking for like main boards for this machine, and I looked at it. I was like, this is amazing. Like I never saw the board before. Like nobody used it. There's also like no reviews online. Nothing. Like it's just no content. Um, I don't know. Like I feel like they should market that a bit more. Okay, let's give this a hot second to boot up. Oh no, I found that's the lever of one of the end stops. It lost. Will it still home? It will still home. Mm. Yeah, the only thing is now like this side will home a tiny bit lower than this side because this side has the lever still. I'm considering just breaking the lever off of both on both sides so they're like even. Yeah, let's just remove the lever on both sides then. Right. That's the second one. Yeah, both click. I think it's even better without the lever, to be honest. Okay, cool. Just quickly like collect all the rest of the dirt. Here we go. Now you have to make it all apart again to put that piece back. Which piece? The lever? No. Crisis averted. Yeah. I mean, worst case, I can switch the. I can swap out the end stop. But to be honest, like if you ever watched my streams before, something like that would not be the first time for me. I sometimes break stuff and then I have to take everything apart and do it again. um, Oh yeah, last stream I accidentally broke one of the fans and we had to take everything apart. I had to fix the fan with a soldering iron, like horrible. Cool, but let's get real. Oh, the printer, by the way, got a name. All my printers have names with C. Don't ask me why. It's just like kind of happened. So this is Cooper. Welcome to Cooper. Um, let's just quickly home X and Y, and then we can home Z. So let's do XY. I guess. Oh, it already home Z for some reason, but okay. I think I copied the. I might have copied the macros from my switch wire here. That's why the homing might have some overrides. But yeah, let's level the bed. So let's just bring this up to like, let's be careful. Let's just put it to 30. I also get my laptop a bit closer that I don't have to hunch over like a madman. Let's trash. Okay. Oh, actually, we also have to change the config. What I always do, and I highly recommend, you can configure the bed screws. So what that does, I can show you in a second. Then Clipper can automatically level the bed for you, like no automatic, but like it can help you. So screw 1 is 8150. So that one was the rear one. So this one should be now on one side. It's not quite correct, right? Like they're really in the corner. So let's just say 10170. What did we configure here is the bed size. In X, because like we can't quite move to the front yet because of this buggy part here. Position max for X is 175, and for Y it's 160. So for let's just set screw 1 to 10 150. So that's this one. Screw 2 is 165 150. Screw 3, let's do this one. Let's just do it clockwise. Would be 165. Let's just do basically 0, which is kind of like here, like because it doesn't quite move all the way forward. And screw 4 is 10 0. Let's do that. Hi there, do that. I name my CNC machines T-Rex, Time Machine, Spinny. Also nice names. Had one named Lisa that actually spoke the key you pressed in a robot woman's voice. That's a bit creepy, maybe. Was from the 80s. That's cool. Yeah. No, I don't know. Like somehow I started naming my printers with C. I have Clyde, Charlotte, now Cooper. Cooper was suggestion by ChatGPT. Okay, let's move up to 20. Now it works fine. We have enough like play here in the front, so this was definitely like a good fix. Everything seems to work. So now you need to remember the name. Screw tilt adjust. No. I always forget it. Clipper, screw. Yeah, screw tilt adjust. Screw. Bad screws adjust. Well. So now we need to do it manually. Okay, so it completely collided. That was good. Cool. I did not expect it to like directly go to Z0. Okay, now we have to home again. So I can already tell you like we need to go down a lot. Let's just like move the bed to the lowest position. And then move it up. Maybe that's smarter. I think you just spelled wrong. I think screws tilt adjust is the more advanced one. Bed screws adjust. And then you have screws tilt calculate. We will do that later. Okay, let me just like really get the bed like to the lowest position. Because the bed now sits quite a bit higher. So that's actually manually move the printhead to 0-ish. Oh, okay. I pushed down and one like the teeth of one of the belts jumped. Okay, yeah, that should do it. Let's quickly home again anyways. Okay, like all the screws are pretty much down now. Let's quickly home one more time. And now basically we need to just see if we can get to 0 basically. No, we can't. Okay, so basically we need to put the Z offset somewhere around. Let's just put the Z offset around 6. Well, I know there's a command to do that. I don't know the command, so I'll just click the button like a million times. Something just clicked. Something moved. Wait, let me actually. Something just clicked. I think that the spring kind of like snapped into position a bit more, which not good, but kind of okay. Why was it now? I'm confused. So now we are at Z10. Oh God, I moved it in the wrong direction. I moved it in the wrong direction. That's quite a massive Z offset change. Here we go. Okay, so now we should be able to move to 0. So that's 5, 3, 4. Now we are at 0 and we have like 2 millimeters left. Now we can adjust the bed. Here we go. Okay. Took a second. Bed screws adjust. Now we just move to the like something jumped here. Like sometimes there's a sound and it's like something jumped. I'm not quite sure what the problem is, but now like we're also like higher. It reset the Z offset, I think. It reset the Z offset. Okay, let me quickly save the Z offset, save config. Oh, hi, Om. I think of buying a BTT Octopus Pro instead of the SKR 1.4. Do you have any other good board suggestions for under 50? You need like 8 steppers, right? Actually, I don't, to be honest. Like, I don't know on the top of my head. You can always combine 2 boards, right? So if you have 2 boards with 4 steppers each, it would also work. But then like with 50, not sure. I no clue. I don't know. It's a warhead. Yeah, it's a mini stealth burner. I just copied like the mount 1-to-1 from the V0, so you can put any V0 toolhead on there. Z offset compared to Marlin. Yeah, Clipper Z offset is straight from hell. Okay, let's try this again. 6 steppers. Well, there's no board with 6 steppers. So, I mean, what you can do is you can also have a main board, and then like there's those extension boards. I know Big Tree Tech makes them, where basically it's just like a secondary board that just has like a couple of stepper drivers. So you could also just go with like SKR Pico or something, like something super cheap, and then have a second main board. If you run Clipper, that is. That's an important thing. If you run Clipper, you can have 2 main boards with like, two, like each main board drives a couple of steppers. Okay, let's try this again. So now we are at 10. Yeah, now we have 0 and there's a bit of space and there's no Z offset. So hopefully now we can just set bed screw adjust and it works. A piece of paper. I don't have a piece of paper. Oh, I do. Yeah, not bothering making this precise because the difference is like so big that like, let's get this first somewhat level. Okay. I used to do it manually. I manually moved to the corners. It's like really stupid. Okay, we're almost there. Doesn't need to be perfect. I mean, we will have a bad probe in a second, so. Oh, no, I accidentally double clicked just it. Yeah. Oops. But I think it's fine already. Yeah, it's fine. Cool. Except we have a level pad. It's super level. It's amazing. Um, abort. Here we go. So this is all homed. It works. We can. I mean, we could do like a test print or something, but let's not waste time on that. What I'm interested in is now adding like a servo, right? Like let's add the probe. Hi there, Big City Tours. M8P that can run CB1 like the M4P, like the M8P, like the M4P on my EndoWire is amazing. Like it's a really nice board. Highly recommended. I think the M8P is even better. Then you can buy 6 steppers. You're definitely over the $50 break point then. Good old machinist tricks. Oh, Kara, I missed your message. I don't know what you refer to, but I guess. Really nice on my underwire. I'm using a Creality 4.2 pool board for triple Z motors and a Duo 2 board for ABE motors. So handy to just slap random old boards in a clipper. Yeah, there's also like my underwire, how my underwire started out. Like I had like SKR Mini E3 V2 and an SKR Mini E3 V3, I think. Like just like random boards that laying around and like you just put them together. And like each of them had one broken stepper, but like, you know, together they made a whole with like 2 extruders. So they worked really well actually. How much duty do you usually pay in the EU or Netherlands? In If you order from AliExpress, which I think you are referring to, the VAT is already on the sale price in AliExpress, so you don't pay any import duty. The paper thing been used by machinists forever. I only know it from 3D printing, but like for 3D printing, it's used since forever. Yeah, blow a stepper driver, no problem. Yeah, I mean, actually, like this one stream where I tried to remove like one of those soldered TMC 2209s and place a fresh one in there. Completely, I wouldn't say ruined the board, but like it did not go well. Cool. Yeah, let's turn this off, I would say. And build some servo action stuff. Cool. Let me just pull the plug. It's actually like also my now I lost the plug. It's also my to-do list to like have a proper on-off switch on this machine. It's like really annoying actually. Mm. How long do you think it will be until our 3D printers are voice activated? Well, you can already do that today, to be honest. Like, I don't see what's stopping you. You could, I mean, it's not perfect, right? But what you could do, for example, is like you can have, I'm pretty sure it works by a Home Assistant. You could do something. You could use the iOS Shortcuts app to do that. Yeah, like I'm pretty sure you can do that. Like it's just like something you have to build. So if nobody built it before and you want it, that's your opportunity. So yeah, maybe let's quickly talk about all these parts here. Let's talk about all these parts. So this is basically just a clamp for the 2 rods together with this. So this goes together like that. And that's kind of like just a mount. Then we have this part that goes on the opposite side, which is then kind of the complete mount. And that's where our servo is going. So that's like an ordinary micro servo, nothing special. That goes here. And this will basically move. Oh, actually, we should 0 that. Oh, okay. Okay, so here's the thing. Like, this is my prototype. I have 2 servos. But let's actually use this servo. Let's take this apart. The thing is that for these servos, like they have like these little teeth here. So you can have the, I don't know what it's called, like this little arm. You can put it in on any random angle. The problem is you don't know the current position of the servo. So this could be like some random angle, which later makes it quite hard to drive. So usually what you should do now is you plug it in and you drive it to 0 degrees, for example. And then you put in the arm in the position you want. And then when you drive it to 90, you know it's at 90. For this one, I know that the position is 0. So let's just take this apart and use this one. Otherwise, we now have to turn on the printer again and drive the servo to 0. And then actually, so let's do it step by step. Nope, my chat is not up to date. Love the crossover of machining and 3D printing. Yeah, I think like there's so much common ground. I mean, in the end, like a 3D printer is just a CNC machine with like opposite material flow. CNC is like removing stuff and 3D printer is adding stuff. I mean, subtractive and additive manufacturing, right? But like G-code itself is just a CNC language, right? It's like age old. Here we go. Let's just have to like get this out of here. Okay, so now we know that the servo is at 0, like the arm is at 0, and it can drive to 90. So let's add this. It's at 0, and it can drive to 90. And these screws just go directly into plastic. So basically, I mentioned in the beginning, this is like slightly adapted slide swipe, which is like a project for the V0. And all I did is, wait, I can show you in a second. Let me just tighten this, not too tight because we screw into plastic. So all I did is, this is the original mount. So I replaced the mount with my custom mount here. And then what I did is like, this is like kind of like the dock where like the thing goes in. The only thing I did is I turned this like 90 degrees. So in the original one, the dock would be positioned like the item would be like this. And I just like turned this fork 90 degrees. That's the only change I made to these parts, basically. Okay, so this is a servo. Then we have 2 arms. There's one arm where we have like a cutout for the servo. So this goes here. And then there's a second arm that's just below. And then what's used are these short pieces of PTFE. So if you want to build this, it's on the slide swipe GitHub. I'll link that at some point. So that just goes on top. And I tried to put it on top. There's like a little bit of elephant's foot. Bad parts. Here we go. So we put the arm here. The second arm goes here. And then there's this little like holder. Oh, that's the wrong one. This one. And it just goes on top and holds the two arms. Let me see. Let's just reuse the screws actually. Yeah, and these are now our two arms. Oh, actually, this is the top side, and this is no, this is the bottom side. This is the top side. Let me flip this around, just that it looks the same. Um, why did you decide to do a servo instead of magnet docking? The reason is that there is no spare room in the build area. So the tool head cannot move out of the bed, basically. So if I would do like a simple, like this is still magnet docking, right? It's just like that the servo moves it in the range of the tool head. Without the servo, I would lose build space. We don't want to lose build space. That's the only reason. Here we go. So now they look the same finish. Now I'm happy. Then the second part, let me also quickly steal the screws from here. We have two more 4mm pieces of PTFE. And just flip this over. So that just goes here. And here. And then the dock goes on top. And that's already the entire assembly of that thing. Like, it's actually quite simple. There's not much to it. I was like, I was thinking like this is like super complicated and like, can I modify that? But it's actually super simple. This is the whole thing. So now it can go from here. Like, this is also like limited, like it cannot go lower because the two arms are now like touching each other. And it goes up. And then in top position, the two arms are touching again. So this like just like physically locked in an end stop position. And that's it. And then you have like this thing here that is like attached with magnets to the tool head. And that just sits in here. And then tool head can like take it out and put it back in. Okay, so to complete the dock, there's one magnet here that I forgot in my magnet box. So I think I quickly have to grab that. But then we can, this one is a little bit of more work to assemble because we have to actually not solder anything, which is good. But so we have to like add the words, the switch. We have to add the switch. And then the other thing is we need to do obviously is like replace this cable because it's way too short. And technically it should already be up and running. Oh, and before I now get the magnets, let's quickly add the heatsink inserts. So we have 2 here. And 2 on the back. I think I planned it for M3 by 12. We will find out in a second. Yeah, M3 by 12 looks good. I was actually figuring out, like later, I could technically mount the dock directly to the bed. Nothing really, anything stopping me from doing that. Because there's like a free screw hole on the side. Then I wouldn't need this part completely. I would need a different part, but then it would be maybe looking nicer from the outside because we don't have this block then on the outside. But yeah, this is the whole dock. This is very simple. Let me grab the magnets. I'm right back. Another one of my magic boxes. With a lot of magnets. I don't think the polarity of this one matters. So this one just sits at the end of the dock. Let's see, can I press this in? Yeah. Nope. Just sits in here at the end. And this one has just a screw head here. And then like it just slides in and the screw head is attracted by the magnet and just holds this like in the end position. Then we need 2 more magnets for here and here. And that's what holds it to the tool head. And then we need a bit of wire. And actually JST connector. So let's head over. Ooh, almost dropped my water bottle. Lucky me. I know we need some JST connector. Let's just head over to the manual and just walk through that. Here we go. So that's the slide swipe. Like documentation is amazing. Oh, we also need to switch. Which I have here. Actually 2. Yeah, so the bomb is really like short. So we need exactly. So this is like 5. And we actually need 2 of them. I also need one for the board where we plug it in the main board, but we can do it later. Let's just crimp that. And to be honest, let's just use the servo cable here. because this will be gone anyways in a second. Yellow is a nice color. Yellow is a nice color. Let's just crimp like one connector on each end of this cable. And then this just goes on either side. Here we go. And oh, I was like, where's my probe? So let me see. So this goes through these teeny tiny holes here. Have you made a laser engraver tool for a 3D printer? No, I don't. I thought about building one or getting one at some point. But for security reasons, I only want a laser engraver that is enclosed, because I don't trust myself enough to not damage my eyes. Okay, now this just looks easier than it is. Okay, just, yeah, I was supposed to press it in already. Okay, let's try to like pull the cables through. Here we go. Okay. Now we have a JST in our like probe. And then they strip the wires, which good luck doing that. Oh, I pulled all the wire. No. I broke it. Ah, shit. Okay. We have to push this back out. Ah, okay. I should have snipped the wire and then removed the isolation. Okay. I also broke the housing now, so that's just completely back to start. Because it was so much fun. Let's just do it again. Let's go for red this time. Maybe red is like a more lucky color. Doesn't start well though. one side. That's I think my crimping crimping karma is gone. Oh yeah. Yeah, okay. That's quite a shitty crimp, but for this use case, let's accept it. Okay. Let's try this again. So first we fill that through. It's not a, no, this one needs to go to this side. This one goes to that side. Okay. You can also kind of push those cables in from the top. To be honest, let's just snip them first to length. Not my day. This direction. So basically just like the crimp just came out. Yeah, this one doesn't really stay in. Weird. I think the nose is not quite. There's this little nose that should be like out, and it's not. Now it is, and I think it will stay in. Yeah, now it's fine. Then let's push this over. That the cable is now like in the left and right pocket. Just fold this in. Like their wire is a tiny bit longer now than ours, but I think this should not really matter. And then we will put in two magnets. So the magnets here, of course, need to match the polarity of the magnets on the tool head. So I will just use the two magnets, snap it on the tool head, and just use a marker and just make a line on one side. This line is now between the magnets, so I can make like another line here. And now we know that the sides with the marker, they need to face down, so we should not see them later. Do they use super glue? Test the continuity between the magnets and the pins. Yeah, they add some super glue. So let's also add some super glue, but be really careful. Because if we add too much super glue, might interfere with the conductivity. Side with the marker goes down. Just pressing the magnet in on the table. No marker, so the magnet should be fine. Yeah, it works. Okay, now let's check the continuity. I hope it's good. Yep. Yep. So that works. So these two basically perfect. Nice. Easy. Okay, now they just add the micro switch from the bottom, which is, I think, the easiest. Don't think orientation really matters. That's quite a tight fit. I'm not quite sure if it's the... I think there's like ever so slight elephant foot on these parts, causing issues with fits. Okay, now it's in. Okay, let's check if it works. So if we press this down, we should get continuity. And we do. Oh, we have to invert it. We have to invert it, okay? I assume this is correct. We need to check the config. Exactly, and then there's this hole here on the front where we add a screw. I'm not sure. I don't think I have this part. Ah, this is the other one. And I added the screw here, which we copy over. I think I'll just let the screw poke out a bit. And then this should snap here in place in the dock. Perfect. And it looks actually quite nice. Then we just need to add a cable and then we're kind of done. So what I would do here, I would just like add like a really short cable. I mean, if I would have smart, right? If I would have been smart, I would have added some zip tie loop here or something. Let's just take it to this length and then just add a JST. Oh, we need to solder that. I always forget. Somebody in the Voron Discord also said like you get these as crimpable terminals. I've never seen them. Okay, let's solder. I mean, I hope we would not need to solder this stream, but that's okay. I have some really tiny heat shrink. What I will do is I will just like snip off like a bit of heat shrink. Primarily just to make it look nice, but also for peace of mind. And I'll just add that on each of them. Go. These cables are a bit annoying. Here we go. 3 cables, 3 heat shrinks. Let's quickly swap out the soldering tip. I think we're also done with heatset inserts for today. Oh, amazing. All the soldering tips for soldering are in the basket. Let me quickly grab those. I'm right back. I have a soldering tip. Oh no. There was one lying here. Okay. Actually, I want this one. I did not see that. Let's put it up to soldering temp. Or this heats up. Let's kind of like get ready. So I would like add a little bit of tin on all 3 tips. And then we can directly solder it. And important here is that we are really, really quick because these melt easily. And actually do not pull on them directly after. I have this like habit of like pulling on the cable after I soldered it. Which is a really bad habit for these. I could just use tools I have, but I can also just use my fingers. Yep, might have lost the heat shrink. Let's see. Okay. I think this center one got a bit too hot in the front. Can we do it? Ah, it's not even like soldered properly. Okay, let's get the heat shrink off and replace that. Let's try this again. Let's add a tiny bit more solder to that center pin. Fresh heat shrink. Now we just have the nice added benefit that left and right we have a connector already, so we have to set solder in the center. Love it. Yeah, awesome. I think there was not enough solder. And here we go. Technically, you know what? Let's just use a tiny bit of VHB tape. And just tape it to the back here. I think I will just add a mount for this JST in the file. And for this one, I think this is like good solution. Could have even been a shorter wire. Cool. Our dock with JST. Let's make a cable. So I have this like a silicone wire here with 4 strands. So let's just crimp a JST on one end and then run the wire and then like cut it at the end. There's one cable with like a marking here, like the all black. So let's just use the black as ground. Like the one with the marking as ground. These are my least favorite connectors. I can second that. Actually, Molex microfit is worse. Now I think about it. Oh, we're almost done. 5 more. And then so far it went smooth. Here we go. Last one on this side. And then just 3 more on the other side. Okay, so now we just need to pay attention. Let me actually clean up a bit. This part we still need. We still need to crimp, but let me still put it back in the box for now. Okay, move all of that over here. And then we can take the printer and mount the probe. So this should go, I mean, the exact position doesn't really matter. So let's just, there's this dirty strip here. Let's just put it over there. Yeah, that's what I mentioned. Like, technically, there's a screw hole. I mean, you don't see it, but there's a screw hole here, right? Like this one. Technically, I can just mount this like dock directly to there, because like on this machine, I only print PLA. It's not enclosed. So technically, the bed shouldn't go over like 60-70 degrees, which ABS can easily handle. I mean, the other interesting part is the servo is relatively close to the bed. So potentially we need to redesign that a bit to like move the servo further away from the bed, just like from, because of the heat. And then just extend this arm, because like we have quite a bit of space here, right? I mean, technically we can move this further forward and like extend the arm to move it like further up. But that interesting part is actually like, does it, yeah, it clears the bed. I was a bit concerned that it's, and I should give me a bit better angle. I was a bit concerned that it hits the bed, but it just clears it. And then the other interesting position point is like if I move it all the way up. Let's see if I can show you. So if we now move the tool head here, I mean, we need to figure out the height and all, right? But the tool head can move over it. And can take, you don't see anything. Oh no. Here, it works. It's really difficult to focus. So here now it's attached. And I can move it out. Ah, okay, I moved it out incorrectly, but you can move it out. Oh, and then now it's on the tool head. Like I can move it out. Oh, it's interesting. We need to, of course, adjust. I mean, it's not like all the macros we need to write. The button here is, of course, below the bed. So basically, the undock sequence will be a bit different for us than on the V0, right? So technically, what we can do is we can basically move the tool head to the position here, and then we move the bed up until here. And then the tool head moves backwards, and the bed needs to move down again. And now the server can be stowed, and we are free to move. So it works quite well. What's your favorite, Kara? So I'm so sorry. I'm sorry. I'm really bad at following chat today. What's your favorite? I think I don't really have a favorite. Like they all equally suck. I don't mind JST too much actually. It works quite well. I'm used to it. I think that's maybe the problem. Once already made, so I just solder the wires together. I had trying to solder the wires on those little pins. I actually don't like solder connections. Like I really prefer like good crimped connections over soldered connections. I always have the feeling solder might break. Like the crimps are a bit more predictable for me. Same seems all ones assemble are annoying. Yeah. They equally suck. Yeah. They equally suck. I think that's a good one. You know what my favorite is? You know, like the Molex, like the good old, like from the old PC days, like the 4 pins, like the power connectors, where you have 2 ground, 5 volt and 12 volt. Super easy to crimp. I like them. Cool. Yeah, let's technically. Oh, cable. We need to do the cable, and then we can. We can. So let's just. I mean, now we kind of like put the cable there. So let's just put a housing on that. And if I have the housing like this, the top one should be ground. So the ground one will be the one with the white strip. And then the next one will be red and yellow. I mean, it doesn't really matter. We just need to pay attention on the other side. Okay, here's the JC connector. Now, let me plug this in, and then we can run the cable. I attempt to plug this in. Okay, it's plugged in. So cable time. To be honest, not quite sure where we need to run this. So technically this can just run kind of along here and then just go into this main cable thing, which is already quite full, but maybe we can get it in there. Kind of need to open this up. So let me just like eyeball the length here and like overestimate it a lot. Okay, so how can I place the printer that we can do that nicely? Maybe something like this, maybe. So we have the cable here. Let me actually get rid of the fourth Yeah, let's just trash it. So we can basically just add 2 zip ties here and there. Then we can add one here. And then we can put it upright. And yeah, now here's this like cable. It's relatively stiff and full. So you already added quite a bit of cables, but let me just try to add more cables in here. This one is a little bit too short to run that route here on the side. As I mean, the cables are all preliminary, right? Because we will move the electronics obviously to like a different place. So I don't bother too much. Like the cabling for the bed is somewhat final, except that I tried to get rid of these 2 Z end stops. It's also connected down here. Let me remove the zip tie as well. Kind of like push this in. Let's actually not push it fully in. Let's first kind of cut it to length and then add the JST connectors. Let me add a zip tie to the beginning again. And then here, so this kind of runs here, and then it needs to go here to this like connector. Let's do something like this in length. Then this one is a ground connector. Let's quickly crimp all 3. Can you do a motion test once you're done? Yeah, I can. We did actually one last sprint, last sprint, God, last stream at the end. It can move fast. The main problem is that I think the frame isn't stiff enough. And from I didn't look into it a lot yet. From the input shaper, X looks really good. Input shaper X is good. Y is bad. I know why. We just need to fix that. Like the Y axis, the XY joints here are not super. They wiggle a lot, and I don't know why. I think it's like has to do with like the way the XY joint sits on the bearing, on the linear bearing. Let me quickly finish this and I can show you. But yeah, I think we ended up with like 10K acceleration at least, and 500 millimeters per second. Like it can move quite quick. It's a light tool head, and it has a NEMA 17 steppers. So like from the pure power perspective, it has a lot. The way they're clamped, yeah, exactly. Like the I changed already. So the problem is initially I wanted to use these the bushings, like the plastic ones, and the bushings were there was too much friction. Like they're designed to have a bit more friction, but it was like super difficult to clamp the bushings in a way that they're not like that there's not too much pressure on the bushings, because like you really could like tighten the screw on the side and then like the entire like bushing was clamped to the rod. So now I switched back to the metal linear ball bearings. That was the last J secret, by the way. And that works a lot better. But now I feel like they're not tight enough from the clamping force. We had a side panel or cross brace could help a lot down the road. Like for now, it's just like this doesn't need to be like a super fast printer. Like just print well. That's the goal for now, and then we can kind of like expand step by step. I could have like also taken out like the JST for that. Okay, let's actually quickly glimpse into the pinout here. Oh, I actually looked at the wrong. It's still fine. So this is the ground, and the ground goes on the outside most. Oh no, I was looking at the right one. This is upside down. So on the outside most. So this one is ground. Okay, ground is in. Then we need to quickly check. So the ground, next to ground is power. So next to ground is power. So this one is power. Power goes next to ground, so that kind of fits. And then a sanity check. Yellow is on the bottom, and yellow is GPR 19. So this is our servo plug, which plugs in here. So let's just try to fill this in, and then we can add a zip tie. And then we can quickly run a speed test. Okay. All nice and packed. Goes in the trash bin. Let's quickly do like I always try to do like triple and quadruple checks when it comes to wiring. So this is ground, this is correct. Ground, well, now I isolated everything. That's of course a bit difficult. Just double checking. So now you don't see anything. No, I don't see anything. I mean, this is the center one I can probe. Oops. Okay, wait. Why this one? Okay. It's a bit difficult, but I need to do this differently. Bit awkward. I don't understand why I don't get continuity here. Let's just unplug this cable quickly. Let's do it like this. So this should be the ground connection. Yeah, check. This should be red is 5 volt. Check. And this should be the signal. Check. Now, just for my sanity, let's double check that brown is ground, red is 5 volt, and yellow is signal, and then I'm happy. Still can't get over the tiny motherboard, yeah. But hey, it has a servo port, so that's that. Micro servo pin or SG90 pin out. So yellow is serial, red is power, and brown is ground. Quadruple check, yes. Okay, I think it's correct. So let's turn it on. Oh, I dropped the cable. This is the magic smoke cam. No magic smoke. Okay. Dropped something. Okay, I just removed the probe for now. Okay, now the fun part starts. The server is engaged. I actually because I tested it out like the prototype before, I actually configured the servo here already. So all I did is here I added this probe servo, which I actually want to rename with probe underscore servo at GPIO 19. And these are the angles that worked for the other one. So let's see. don't save. So if I look at my history, this was my test, and this should deploy the probe and then retract it again. And that seems to work. So the angles I just figured out by trial and error. So I don't fully understand servos, so for some reason I have to give it like an angle of 100 to get an angle of 90. 90 is like not this, is like more like this. There you go. We have a servo. Very nice. Okay, then I think like let's just return to the docs. Because they have all the macros for us. We have to modify them a bit. But generally they should work relatively well for us. Okay, homing still works. Your build plate is a little off. Yeah, I mean, thanks. Obligatory, it's a live command. Yeah, it's very important to see that's still kind of like that's what it's supposed to do. We did all the hardware. And that's where they built the arms together. We connected it. It's amazing. Yeah, they also connect the probe to the same port here. No. So this is basically just a build touch. For us, the end stop is actually wired to the toolhead board. So homing override we don't need because we will not use the probe to home at the beginning. We do need the probe section. So we have the probe servo. Let's copy the probe section, and I want it with underscore. Probe. Okay, check. Random bad mesh works for me. Mesh min, let's just say let's keep the values. They are for the switch wire, so let's do for the V0. So let's just do 155. 155. Then the servo we already have, that's configured. And then they have the macros. So let's just, at some point I have to clean this up, but the pickup position we need to figure out. I'll just leave it like this for now, but that's something we need to do. Then deploy, and the angle is 100 for us. That's what we had in the other command. Wait for deploy. Retract, angle is 0. Probe service, so we turn off the servo. Yeah. Take probe. The only thing we need to do here, because the pickup pos basically will be in a way that the micro switch will be like below the bed. So after we do this, we need to move like, let's say like 10 millimeters down. Mm. So let's just say plus 20. So the bed moves down 20 millimeters, and then we can easily clear it. And for the stow, we go to Z plus 20. Then we go to X, Y. And then we go to Z. And then like it's the deploy, and then it slides in, I think. Okay, let's leave these as is. I have no clue if that works. Let's do that first without the probe, because the probe could collide with the bed. Actually, it would be smart to just prolong the arms a bit, like to just make the arms longer, that you don't have this collision problem. Can you speed up the servo motion? I've never used an actual servo motion. No, I think it's a fixed time. I'm not an expert. I think it's just like the set angle, and then that's the thing. The servo will move to the angle. How it works is basically there's only one signal line, right? So the signal line is just a PWM signal, so like a high-low wave basically, and the percentage of PWM signal just sets the angle in percent of the full range of motion of the servo. It's super simple. Like you cannot send any signals. There's no like digital communication. It's just like angle. I think technically you could slow it down by just like sending like a set of angles, basically, you know, like steps. But I don't think you can make it faster. Okay, PC14 is not. We should have updated the pins. So probe. This is something we need to check. This would be from the EBB36, which is the toolhead board. And I just want to see the pinout, please. I just want the pinout. Here we go. Let me quickly check where we connected it, actually. We connected it to the end stop. So the end stop. No, that can't be. Woo! Did I screw up massively? So this is what I see here. It's not focusing anymore, but these two white cables are what are connected to the magnets. And according to the pinout I'm having in front of me, I connected 5 volt and ground. Which is like, you can do that. It's just gonna short out. So that's not good. I mean, if that would be the case, we should measure 5 volts across the magnets. Let's quickly check that. So if this gives 5 volts, I screwed up massively. No, this gives 0 volts. Okay, let me quickly check if this is the correct pinout. EBB 36. GitHub. I'm very confused now. Mm, no, wait, it's these. Yes, says 5 volt and ground. I'm really confused because I don't measure 5 volts across that. I'm pretty sure it didn't screw up this big. Oh God. I completely mislooked. There's an empty pin in the center. So this is 5 volt and PB6. PB6. Okay. Whew. I already thought like I made a massive mistake. So PB6. And we need to pull down. What was pull down again? Wait. Clipper config pull down. And con 0? Can 0. Yeah. True. Steve, you're right. I missed the thing. It's the wavy thingy. Yes, I need to. I think I called it EBB. EBB. So, where is it? Probe. So it's the wavy thingy EBB PB6. So it's a pull down, and then it's connected to 5 volts, so it goes up. I think the offset should be okay, I guess. I have the same tool head. Let's check anything else. No, there should be no other pins. Okay. Let's home. We don't do the end stop. First tests. Let's just do a probe accuracy. Like this should run the whole thing. I'm ready to emergency stop. Probe triggered prior to movement. So we need to invert it. So at the moment, probe is triggered. So we need to invert that. Probe. So it's not. Oh, is it the other way around? Is it like wavy thingy exclamation mark? Yeah, wavy thingy exclamation mark. Now the probe is open. I will quickly put it on. Let's hope nothing goes wrong. Probe is still open. I press the button. Probe is still open, so it's good. I'm not sure if that works. Let's see about that in a second. Let's quickly do the accuracy test. Wavy thing. Yeah, I don't know how this is called in English. In German, it's tilde. Okay, so no, I think that the probe button should let's quickly go through, and I will like emergency stop after it picked up the probe. So it moves up. It hit the bed. Emergency stop. I was pretty quick with that. Very proud. Same in English. Well, then tilde. My pronunciation most likely is different. I like wavy thingy more. Maybe we should have changed the position. But Z is 30. Let's just set Z to like a 100, just like super high value. Let's home. Okay, I do the... Actually, let's quickly check for the exact macro, then we don't have to like panic emergency stop. So it's SS deploy and retract for the server. So it's SS take probe. Let's just run SS take probe. Oh, now it says the value probe server is not valid because I underscored that. Let me just search and replace that. Save and restart. Let's home and then take the probe again. The emergency button is ready. Perfect. Now we just need to figure out the position. Let's first figure out the XY position. So I'll just move that to 30. Let's do 20. And then we just have to like move it now in position. So let's deploy the servo. Let's put the thing in. And let's I'm just trying to eyeball that here. Okay, so X is Y is fine. And then And let me also try to do Z. Okay, I think this is a good position. So we are at these coordinates here, whatever this is. Let me just quickly take a screenshot of that. This is our position. So we still need to change the routine a bit, I think. So the take probe, it should move, not Z, it should move X, Y to the exact position X, Y. Then it deploys, and then it moves to Z, to the Z position. So it sits on top. And then it goes to X. So it takes it out. So it's X plus 40 or something. Let's do X plus 50. And then Z moves down. This should work. And then for stow probe, it moves to Z plus 20, X, Y, moves to Z, moves it in. Let's see. Let's see. Okay, let's home everything and off we go. You need to go Y, then drop Z before X. Yeah, I think you're correct, Steve. I think that's what I just did. I do like everything too, yeah. Okay, let's just take probe. Off we go. That's the wrong position. We did not update the position. We did not update the position here. 16950. 84. 98. Let's try again. Oh yeah, by the way, the server will retract like when you start Clipper. Yes, I need to home first. Let me also give you like a view a little bit more from the front, maybe. That you can see what the probe deploy is doing. That was a bit too quick for my liking. That was a bit too quick for my liking. But he got it on the right spot. Let's put the Z movement down a bit. That's 5,000. Let's do 3,000 for now. That was just uncomfortably quick. Oh, it says move out of range. 2, 9. It has a really high Y value now. I mean, it docks correct, and then like it says like move out of range. 2, 9, 15, 80. Let's quickly check. So it's a really high X value. Oh, X plus 50. What I meant was Y plus 50, so that it moves back. Yeah, here's also Y plus 50. Yeah, my bad. I want to. Luckily, Clipper prevented any bad things. Yep. The servo isn't servoing. Wait, let me quickly check. What was the macro? SS retract. Like this one has a problem now. Let me just run the test script we had before. Oh no, what happened with the servo? Let's do quickly firmware restart. It's really hot. I think we fried the servo. I don't know what it did. I think. I think we fried the servo. By we, I mean me. I don't know what I did. Let's quickly try the other servo. Hmm. So if you send the command with 0, it turns the servo off. So let me just quickly see if that reset it. No. Okay, I think the servo is broken. I mean, I have a second one. That's a bit of a bummer. Servo is off, so let's just quickly swap it out. That's weird. How does the servo know what position it is? So the servo is basically like a normal DC motor, and it has a potentiometer, like one of those poties thingy there, like one of these basically. And then basically, depending on the position it is, like the resistance changes, and it just measures the resistance of that thing, and that gives it the angle. Even if it tries again, it should not die. Okay. Well, where do I have the second one? Where do I have the second one? I had it in the beginning of the stream. So it can't be far. Ah, here. Okay, very sad. My only regret is why did we use a DuPont connector here? Now we have to solder it again. It does no matter what. Yeah, it always knows. Immediately, like you power it on, it knows the position. Yeah, I mean, I should figure out why it fried, but like I don't know what I did. And I don't know how I would figure it out now, to be honest. I mean, it worked fine, and then suddenly it didn't. I mean, I moved it manually, but I moved it like with the prototype the entire time manually, and it was never a problem. Well, it's just Google. I mean, maybe we did that, but like, not sure. I think what might have happened when I did the clipper restart, the magnets held the probe, and the servo tried to move it down. Maybe that was the problem. Can you do get angle? No, there's no get. There's only one-way communication. You just send the servo like what position you want it to be. That's the yellow wire. There's no communication. There's no digital I/O or something. Okay, if we want to do this, I'll quickly plug this one in. So this one is now plugged in. This is the second one. I will run this now to 0. This is now in the 0 position. So now we know this is 0. And then we can run it to 100. Which should be pointing upward now. Okay. Okay, this one is like now in the proper position. Let's turn it off. It's off, we can unplug it. Hey, what a mess. Okay. There is a tiny screw that goes here in front. So basically what we just did is we just zeroed it out. And now we know that this arm like this is at 0 degree. And then this is basically 90. So we can wait. No, this can't be correct. So it goes in like this. Goes in like this. Oh, the arm needs to be exactly the opposite side. Otherwise it can't do the movement. So we just need to flip this like 180 degrees. Okay, so now this should this should just fit. There we go. Yeah. Okay. Let's just quickly test it once before I switch the plug. Man, that's annoying. Um, can you step it to 95? Yeah, we can do that. We can do that. But it should not die if you step it out of range a little bit. Like it will push as hard as it can and it cannot reach it, but like it's not immediately gonna fry up. Angle debug read. I don't know what angle debug read is, but I guarantee you, you cannot read the angle of a servo. Okay. So I'll just put it in the center position. It's plugged in. Okay, so I move it to 45. 40. Oh, without the with 0. So this is 40. So let's move it to 10. So this is 10. It's almost down. So we can just rest it at 10. Let's move it to 90. It's almost upright. It's not fully extended. 95, 96, 98, 99, 100. There's still a gap, so it's definitely not at the top position. And wait, 5 was almost down, but not quite. So how about we just do it from 5 to 100? So this one seemingly is a little bit different than the previous one, because like 100 definitely was like perfectly straight for the last one. So 5 to 100. Okay. Five to 100. That's solar. I thought we were done with that stuff. It's even the annoying solder. Get a new one. And I thought we would be done quickly. But then, as Steve likes to say, it's like, wouldn't be one of my streams. Where's my tiny? My tiny heat shrink. I think this should also work. Now we just need to pay attention to the pinout matches. So yellow goes top. Red goes center. This moving is not really helpful. Let's double check. That looks the same to me. A new plug is born. Oh no. I wanted to make the cables a tad shorter, and now they're like really short. That's like a classic me. Like I want to make it a bit shorter, and then like it's like hyper short. Yeah, it also works. Haircam. Oh, sorry. Sorry. Um, Figure out my pinholes in the parameters issue. One of you is just heard in the background that the server died. Yeah, one less server on this world. I'll check it out later. Maybe if it cooled down, like it recovers or something. But it's also like not like a huge financial loss. So I'll recover. I'll recover. And most likely we also just ordered like a 10-pack of these. They're not expensive. It's kind of like a cool thing to have. Always good to have spares, I guess. Okay, let's put that bad boy back up. Okay, it's plugged in. Let me get rid of the soldering iron. Okay, also have to plug it back in the back. Actually, did we update the angles here? Yeah, we did 100 and we set 5 for here. Should save and restart. Oh. I think also the servo is configured. Yeah, now it's engaged. It shouldn't be engaged right now. Yeah, right now it's like engaged. Now it's... I think what happened is that the servo was constantly on. Because I have the initial angle 0 here. Let me remove this. And maximum angle we just set to 100. If I set it to 100, it will change the thing. Let's do it 135. What? What problem now? Some I had it before with this machine that like it did like a restart and didn't come back online. I had to restart the whole machine. Let's quickly reboot. Here I'm looking for a sponsor for our show. I'm so sorry, guys. I'm trying to do my best here. Okay. Maybe. Will for another server? Place your bets. I say yes. I say yes. Surprise, yes, no. Yeah, I'm doing my best to not try any drivers anymore. It's a relatively expensive hobby. Okay, so now the servo did not engage, which is great. So now I just drive it to 0. It's a 0, and then I expect it to like, it stays on. Now it's off. So let's do 100. Now it's at 100. And it holds 100. But it shouldn't be a problem to hold 100. How about we just don't park it like all the way at the end? Like we can park it at like 30. This is low enough to not make any problems. Like this is low enough to not make any problems. It's still like below the bed. Maybe let's do 20. Let's park it at, yeah, I think 20 is nice. Then it has no stress. Like it never reaches like the full range of motion. So let's go to the retract. So this is at 20. Not hot. No, not hot. Okay, let's do SS deploy and SS retract. Not sure what it was, like not sure if you saw that. Retract. Is it fight right? No, I don't think so. SS deploy. Retract. Just like when you do retract, like it doesn't, like it does 2 steps now for some reason. Like it does the movement. Let me just retract it to 0 because afterwards it's shut off like immediately. Deploy. Retract. Yeah. Yeah, I think the second movement, I see is that off here, which is fine. Okay, the question is if we now, if the position is still correct. Let's just try it out and see what happens. Seems like it's going. No, I think like it's just like it goes to the position, then waits half a second as per script, and then like it turns off, and then like it just releases tension, I guess. It seems good. Like they also should not go bust like if you move them out of range. Like not immediately. Um SS Tech Probe. Off we go. It moves the wrong direction. SS Take Probe. Like this is all good. Oh, G1X. Oh god. I go G1X and Y plus 50. Success. How about we move in Y? Do I have to mistake somewhere else? No, the rest looks good. I saw it earlier, yeah. You should have told me. You should have told me. Or if you told me, I might have missed it. Also possible. But not the end of the world. No! It all, oh, you didn't see it. It didn't quite move far enough back, and like it kind of snapped it off at the end. But besides that, it worked. So let's quickly change in the config. Let's just change the 50 to 60, just to have a bit more buffer there. Let's try again. Oh, we also have to put the probe back. Probe taken. Let's stow it. It first moved here and then moved over. Let's check that. Let's check that. So stow probe. So it moves to Z plus 20. Then it goes to X minus 20. That's incorrect. We want it to be on X. And Y back. Then it moves Z. Then it moves X it is already, so we can remove that. Then it moves Y, and then moves X over. Now it should be correct. I have the same issue? Where? Y, Y, X, Y, Z. I don't see it. It looks fine to me. T, it looks fine to me. Let's try. Oh. Well, it's X and Y in the same line, but like it's two movements. So that's take. Can we do stow? We can stow. It's stowed. Take. Stow. Hey, that's cool. That's cool. It works. Um, probe test accuracy. No? Probe accuracy samples. Let's not do like 100. Let's do maybe like 10. Oh, maybe it should have picked up the probe first. That would have made sense. Why didn't it take the probe? I feel like something is missing from the config. XX is a little too far. It pushes on the outside fork. X is a bit too far? I'll check in a second, Steve. Um, let's... I'm still very new to macros. Yeah, it's quite complicated, actually, I think. Says the software engineer. Let's quickly check. Maybe it was a take probe would have made more sense. Yeah, it's not really bending, but yeah, I see what you mean. Let's just nudge it over like a millimeter. So let's just do 1.8. 8. I'm still like a bit confused. Like, how would you tell Clipper that you take the probe? I think like for the probe accuracy, you first have to manually take it. It's not smart enough to automatically take it because you only override the G29. Yeah, I think now it's better. Steve, that's better, right? Looks better to me. You probably need to make a macro for the probe accuracy test. I think it's fine. Like all you need to do is you have to say take probe, and then you test the probe accuracy. And then maybe not next to the bed. That's also like step by step we figured out. Let me put this in here. Okay, so we home. We say S is take probe, we say center, and then we say probe accuracy. This will work. That did not work. All good. We remember when it said we determined that the probe didn't trigger. It doesn't trigger. Yeah, I think everything's fine. Don't do it at home. Cool. Let's figure out why this doesn't trigger. I mean, it might be the micro. When we did the ender wire, we had the same problem that like it doesn't trigger, the switch doesn't trigger. It only triggers like it's kind of like debounced or something. I do have another one. Let's swap the switch. Ignore what you're looking at here. That's like a surprise for like a future stream. Have you ruined brand new bats doing this kind of stuff? Yeah. I think we all did at some point have some issues with that. Trying to like wiggle this out. Here we go. I mean, this one has a thingy, but we can remove that, of course. Let's try this one. I quickly put the screws back so I don't lose the screws. Okay, let's quickly end stop query. Yeah, it doesn't work. It doesn't trigger. So now it's always open. So it's not the switch so far. Let's check the config. Animalistic tag, yes, servos and clickies, and it's deploying. Like we can like pick it up. It's just like the switch doesn't trigger. What tab is that? No tab. Surprise. I mean, it's not a big surprise. It's basically, yeah, I can show. This is, yes, similar to what you have on tab. That's just a CNC mount for the switch wire. Because my switch wire goes really fast by now, and I have problems with the printed mount. And I broke 2 printed parts on the mount on the switch wire, and I'm kind of fed up with it. So now we add a CNC mount at some point. That's like a filler stream. At some point, if I don't have something to work on here, we'll install the CNC. The circuits through magnets work. It should. We tested. I mean, at least this side we tested. I think the other side we tested recently. That's actually a good one. We could try that. Now the circuit should be closed. I just put a like. Now it's closed. No, it says open. That might actually be the problem, Ballistic Tech. How do we test that? I guess we just check the continuity. So close. So this is the front magnet. Yeah, this is continuity here. And it's the back magnet. Which indeed has no continuity. Okay, well, that explains a lot of problems. Ugh. Well, let's take the tool head apart. That explains a lot. I feel like we tested that. Like we put the tool head together like a while ago. I feel like we tested that. I mean, it might have broken over time. Let's see. Just to double check, so the rear magnet has no continuity to either. The front magnet has continuity to this one. Now, how do we fix that? Problem is the magnets are of course glued in. So that will be quite a pain. Let's start with the zip tie here. Oh, I see what happens. I think. Oh no, I thought for a second that like the wire was broken under the zip tie, but no. Let's start with some IPA to like remove the glue. I have very low hopes for this. I think it's actually the front cable here. I think the rear cable goes through to this one. How to get this out? Here we go. Oh God. there's super glue on top of the cable. Sure if you can see that. The glue ran between the cable and the magnet. Amazing. Let's do the following. Let's snip the tip. Normal stream. Yeah, Steve, I know. I know. It's actually, you may as well start printing a replacement part. Why you do that? No, 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 no. I'm not giving up here. Although I'm really not happy with the print quality of this one. Like, it's just like the shape here was a bit weird to print. Okay, I'll just leave that in here. So let's remove a bit of isolation. And then we just have to carefully move this in here. Okay, now I put a magnet on top again. Let's check continuity. Now we have continuity on both. Okay. Let's add the ever slightest bit of glue to the back here. While we're at it, we can actually just straighten out the V6 is not straight. Where's my... Oh, I fell down. Okay, it doesn't want to turn. Oh, here we go. Okay. Let's quickly just turn the printer on like this. I mean, everything is plugged in, everything is fine and safe. And then we can quickly test. Up the side of the magnet as you push it in. Yeah, also better maybe. But yeah, I think now it's fine. Do you have to make the glue on an edge? See, I think there was like the intention here. Like I only had glue on the edges, but it seems like I put too much and it ran down. No clue. Also on the outside, there's no glue. Yeah, I don't like. It's fine. Like 3 out of 4 were fine. This was the only one having this issue, right? So let's see. So now probe is open. It's still open. Right. Let's quickly check. So if I like bridge these two, this is continuity. And when I press the switch, it's no longer. If I put it here, these two have continuity. But the switch doesn't change anything. So I would guess these two cables are shorted out somewhere. Because they also now have continuity. Somebody did a really bad job putting that together. I wonder who that was. So here we go. That was harder than expected. So these two should not have continuity at the moment. I mean, if I ever get to... And they do not have continuity right now. I think then it's like a software configuration issue. Like right now, they don't have continuity. And if I now put the plug on, this is so annoying to measure here. Now they have continuity. Now they don't have continuity. Speak of having like a third hand. I literally have a third hand. Okay, so there's continuity. You don't see it, but I'm pressing and depressing with my thumb down here. Now it stops beeping. Beep. If I don't miss the pin, man, this is like annoying. Yeah, but now it works. So I'm pretty sure the ballistic tag is correct and it's a pull-up resistor config. Because right now it should work. I don't see why this should not work. Let's try one more time and check the config. I've watched a few people with Clickies. Everyone had issues with the magnets. Yeah, the magnets. I don't know. Like, it's a cool concept, but it's a bit finicky. He did change the switch, but I do not remember he changed the config after. We'll find out in a second once this is back up and running. Heideltinger. Connecting. Come on, you can do it. Okay, let's check. So probe. We have a pull down resistor. Let's just change to pull up resistor. So I can restart. End stops, open. No, I should still say open. Yes, like no matter what I do, it's always open. I could check. What did they have here? Probe. They just have a. They have a pull up. Oh, here's the probe section again. Probe. I mean, they have a pull up. I have it inverted. But like to be honest, like at least I should do something. Like should change the state. Right now, it just doesn't do anything. Now it's triggered. But now it will be always triggered. Yeah, now it's no matter what I do, now it's triggered. So it's like not inverted anymore. Well. Uh PB6. Steve, are you saying that I used the wrong pin? Where do we have I have PB6, yeah. It's 5 volt, ground, and then the PB6. That's exactly what we have here. So PB6 is fine, unless you tell me that I don't have PB6 here. Yeah, PB6. PB6 should be fine. There are Apple MagSafe like connectors on AliExpress. I used them actually before, and they are even more horrible. Because like if you start soldering to those pins, like nothing sticks, like they break off immediately. It's really bad. So I wouldn't want to use that, to be honest. How did they connect that? I'm feeling a bit stupid to like not get an end stop to work, to be honest. Like this is not rocket science. You say something? Normally close or open. Well, ballistic tech, it doesn't really matter, right? Like at least like when I press the switch, like it should change. That's like my expectation. Like maybe it's inverted. But it should at least change. And like right now it doesn't. And we tried 2 different switches. They both do the same. I mean, now technically we can put this one back because this one was a magnet why it didn't work. But yeah. Silly question. That sounds like something. Usually between signal pin and ground. Yeah. I wired it on 5 volt, but it should also be fine, right? But don't work from 5 volt to ground, no matter. Well, let's just quickly change it, to be honest. So at the moment, we wired it with 5 volt and GPIO. That's also why I used the pull down resistor. So let's just like quickly change that. Maybe I'll just put it in the wrong thing. Let me try to yank this back out here. So the outside one needs to be moved one in. And I don't want to I don't want to recomp that. Okay. Let's recrimp that. I really hate these cables. Like, they're way too thin and fragile. To be honest, I should just redo these white cables completely. I don't know, like, who asked about the least favorite crimp connectors I had? J's TPH, by far. They're just way too small. Okay. Before I completely put this in, like, let's quickly double check. Yeah, so one free, then ground, then the PV6 connector. Okay, here we go. Let's check. So now it should be, they use the pull up resistor, right? Yeah. I just want to have one bad match today. That would be so cool. So we now have the probe with pull up resistor exactly like they have it. End stop is open. I press. Oh God. It works. Okay, end stop's ground. Okay. Let me quickly replace the switch then. So this one can get ready for its duty in the other build. And this one quickly goes in. Let's test that. So now it's open. Now it's triggered. Okay, so this switch also works. Okay. Okay, let's put the tool head back up. Oh, let's actually, before I do that. So here on the bottom of the where the cables are, I'll put another little dab of super glue there. That's also what we had before. Just to like hold the cables a bit because they're like quite fragile. Okay, okay. Last steps before we can probe, I think. Okay. Okay. Now it still says triggered, by the way. Now there's nothing here, and it still says triggered. Oh, that's cool. If this is missing, it still says triggered. As is very handy. That would have prevented the issue we had where we tried the accuracy test and it didn't have the probe on it. It just says immediately triggered. Okay, let's try home. Ballistic tech, now you can observe, witness the pickup. So we have SS take probe. It works. Is this now good? It has a precision of 0.01, so I would say like that's okay. So now we can say SS slow probe. And that's it. Let's actually reduce the Z offset a bit. At the moment we have 20, like the safety distance. I really should just like prolong the arm by like 5 millimeters, and then like we wouldn't have the issue at all. Let's just not do 20. Let's just say let's do 5. 5 should be fine. Fail safe, so it knows if the probe actually got attached. Exactly. So it's really good. Let's actually put the probe back. So here's the fun part now. The problem is that I still need these two end stops here to home the bed first, right? So what I was thinking, and that might be far-fetched. Right now, like if it moves up, I could detect the moment when the probe connects, and then use that as a Z and stop, and then basically do the thing, the probe to home Z. That's for like another time. Yeah, this is now like, that's already enough Z-wise. So let's do the following. Let's just create a bed mesh. It probes quite a lot. It's like very high, but it looks not too horrible. Hey, we have a probe. Really cool. Now we can do SS stop probe. Now the question is, what happens if we do G29? So it does everything perfectly. Nice. Let's quickly check why it does so many like tests. Samples 2. Let's just say samples 1. Oops, I'm pressing escape. um, oh, it has sample tolerance retries. Ah, that's why it takes so many. The sample tolerance is really tight. To be honest, I hear some weird sound. So I think the problem is that the tolerance is not quite tight enough, but it could just be the Z system I have, to be honest. That might be just some problem there. I'm not quite sure if it's like perfectly aligned. I think it needs to be a bit more further down. Yeah, it needs to be a bit further down. Like, let me just show you from the. So if I take it, I think it's kind of fine. But if I stow it, like the arms go a little bit like this. I think it needs to be a bit further down. Yeah, it's a bit high. So let's just quickly change the position ever so slightly down. So it's just like 9 point. Let's do 9.6. So it's like 0.2 lower. Put it back. Let's try this again. Yeah, well, that looks loose in front. It should be fine. What happens with the bells, I noticed that, it's like the side that's wait, now let me focus. Yeah, now it's better. That was all it needed, like 0.2. The belt is, oh, this one is actually very loose. You mean this one? This one actually is very loose. That might be the issue. This one is better. Um, should be able to set up Z tilt to tilt the bed to the X. Might give better bed mesh and might be worth hard mounting the bed with auto spaces. The problem with Z tilt is that I cannot do 3-point leveling because I only have 2 motors. But if you want to have like a full Z tilt, you need at least 3, right? That you can adjust the bed. So because I only have 2 motors, I still need the springs. If I would have had three motors, or in this like 4, I could with 4 I could have done like quad gantry leveling. But yeah, like this is something I have to check. They all are a bit different. I'll need to check. Like this one is definitely too loose. That might be most likely the issue already. Just speculating. I saw it moving weird during the test. Yeah, that might be like it's quite loose. And let's just. Maybe it was on a pulley or something when I tightened it and I didn't pay attention to that. I mean, let's just quickly try. Um, ha! Probe trigger failed. Very nice. Not sure why it didn't take it, but yeah, it still like takes quite a lot of attempts. Yeah, here's 2, 2, 3, 4, 2, 2, 2, 2. Looks better. Like it's extremely flat. I'm very confused about that. This is not what I expected to look like. And it's a 3x3 mesh, but still looks not what I would expect. But yeah, I would say let's call today. It's almost midnight, and I count it as a success. Like we have a new bed mount, which has some problems. So I'll definitely have to reprint the files, and we will have the pleasure of remounting the bed again next stream. But yeah, besides that, the probe works, which like to be honest, like I was way more afraid of the probe not working than the bed mount. And here we are with a perfectly working probe, but like the bed being weird. So you can't have it all. Why is the Prusa bed not an ender? Well, so initially, when I was like designing the machine, like my goal was that you can scale it up and down. So I wanted it to be either like working with a V0 bed or working with a Prusa mini bed or with the Ender 3 bed, that you basically have like 3 size options. But actually this is really difficult to keep in mind all the time, because like already I can tell you that certain things will not work with the V0 size, just like because like there's not enough space. But yeah, like with the up, no, the end stop is back where it belongs. with the old mounting system, which was this here, right? Like where we basically had like the rods going across, and you had like two or one or two of these. This can mount the ender bed. You just have to like make the size big enough to fit, right? But this can mount the ender bed. The problem with this one here is now basically that it doesn't mount an ender bed out of the box. But I forgot who, but somebody mentioned that like we can like make these arms detachable. And then again, like you could have like different arms for different beds, and it would work again. But yeah, for now it's the pusher bed. It's just like the size I want to go for. And to be honest, I feel like the bigger you go with the printer, the more problems you will get. And this frame might not be sturdy enough for a bigger machine. For this machine, it works well. Somebody asked for a speed test. Let's do a speed test. It can go fast. Let's maybe detach the probe for that. See, it was you. Here you go. I just hold it for now. I don't have to hold it. I can do it without. So that's not full speed. I forgot what we tried at the end, but I think I can do 20 with 600, something like that. It's also like I didn't tune the steppers at all. How do you do speed test? Check out Alice tuning guide. You will find the macro there. I can also send it to you. It's just a macro. Let's try this one. So this is 20,600. Now I have to hold it. So it can go fast. Is this like realistic printing speed? 1000% no. You see like everything is kind of like shaking a bit. Like it's there was like this thing with the Rook. The Rook, if you did it, if you ran the speed test, like it walked backwards because there was like too much weight on the back, and then basically like the inertia basically like moved it backward. But yeah, it's quite a quick machine. It's light, it has big steppers, so it's fine. Cool. Thank you very much for tuning in. That was like quite a lot of fun. I'm still like super happy that this works. We can optimize that. Like this will not be the final iteration, but like the concept works. And yeah, it's more and more starting to be a printer. In that sense, see you next week. Have a nice evening. Bye.